Okay guys, now that you saw this video, we're going to continue on the key language, okay? Let's start by reading the key language. The key language is called states of matter, okay? So, let's read it together. Everyone's on the key language, computer science, yes? Great job, okay? It says, the states of matter. When you hear the word water, you probably think of the liquid you drink. However, water turns into ice if you put it in the freezer. Or it can be water vapor after taking a hot shower. How can one substance have so many forms? Everything around you is made of matter. Pencils, air, water, and yourself. Matter is made of particles, which are microscopic structures only visible with special microscopes. Depending on how molecules are structured, there are different states of matter. Do you know how particles are formed? Does someone has that idea how can this be formed? Great. Now, I want you to observe to your right hand. There are these key concepts, okay? And it says states of matter, plasma, and plasma TV. Oh, are they talking about electronics now? Let's see, okay? Now you see these images. Let's try to figure out what are they about, okay? So let's start with the first one. The first image says protons, electrons, and neutrons are the three fundamental atomic particles. So right here you can see the three different colors that can classify or that you can recognize the particles according to their characteristics. Okay, there's protons is red, neutrons yellow, and electrons blue. Okay, next image. Protons and neutrons are bonded in the nucleus of the atom, and electrons orbit it. So the yellow proton, the red one protons, and the yellow neutrons are in the center, they're in the middle, and electrons are around, okay, like making this orbit, making the circle around the other ones, okay? Now, let's see the other image. If two or more atoms are connected by a chemical bond, we call it molecule. Molecule is when these two atoms, okay, are connected and they form this molecule, okay? This is why the water this substance has many forms. The last image, for example, water molecule has two atoms of hydrogen and one of oxygen. Okay, and there you see the representation of this. Now let's continue in the bottom part. It says, the structure of water molecules is always the same. However, depending on the arrangement, the state of matter changes. Do you know how many different states of matter are there? Does someone knows before starting in seeing it? Did someone already knew what were the states of matter of the water? Great job. Maybe you know them. You have seen the transformation of this substance, but maybe you don't know the process or the correct name of the process. You know that water, when you put it on the fridge, oh, it's ice. It gets cold, it's ice. Oh, but when you put it in the water, what happens? It starts melting and it becomes liquid, okay? Now, if you take a shower, but a hot shower, that little smoke that you see is water vapor, okay? But now we have to know what are the process of these forms that can change the water station. So let's see. Solid. In solids, molecules are organized into regular patterns that hold the matter together. This is why they are firm. Firm is that you can move it, something that it will stay in its place, firm, okay? For example, when you touch an ice, it's firm, you cannot even break, you can break it, but like it's there, it won't break by itself until it starts melting or until you put a heat, okay? Or something hot, okay? Liquid. The particles of liquids are also arranged closely together, but not in an organized pattern. This is why liquid can take the shape of its container, okay? Here the liquid, the particles of the liquid are not firm, they're not tied together. This one is a little bit close, but not too separated. So that's why when you put liquid, you pour this water inside your bottle of water, the liquid makes the form of the water, okay? Gas. The molecules of a gas flow freely and have no specific formation. You can walk through steam, smoke, air, because they're all are gases, okay? Gases, the molecules of the gases are a little bit more separated. Let's continue. It says, liquids, solids, and gases are the most abundant states of matter on our planet. However, things are very different in the rest of the universe. Other 99% of the matter in the universe is plasma, the fourth state of matter. Plasma is formed when the atoms of gas are ionized, okay? So now let's observe this image. Okay, so now let's look at this image and we'll click on the little circles to know more about it. Okay, now the first image says, when energy hits a cloud of gas, it pushes the electrons out of the atoms. This is called ionization, okay? You can see the image, the protons, the neutrons, and around it, you see the atoms and the energy, okay? Now let's see the other one. Okay, the second one says, due to their electronical charge, ions can be manipulated with magnets, okay? For example, I don't know if you have done this, but I have done it with small magnets. I have used it, and sometimes I use it to grab my coins, because sometimes I have nails, right? And then this coin falls on the floor and then I can pick it up. So I find a magnet, and with the magnet I just pick it up. You see how the magnet has a lot of energy, or it has these things that help to grab things, okay? Due to the energy or the ions that the magnet has, it let us do several things. Okay, the third image says, a lot of energy is released when an electron is released through ionization. Then this lost electron hits another atom, which liberates another electron, and so on. And there you have an image of this type of representation. Let's continue. Okay, this other image says, the ionization process creates an electron and an ion. An ion is an electrically charged atom. Okay, and you see the image where you have the electron outside, the ion, and inside you have the neutron and protons, okay? Okay, and now underneath those images that you already saw, it says, have you ever heard of plasma TV? Why is plasma inside of a TV? Oh my god, I didn't even know this. Let's check this out. Believe it or not, the same thing that occurs in the sun happens inside plasma's TVs. Plasma grows so you can watch your favorite show. So, in my words, according to what I read, I understand that plasma, it's like this substance or this substance that allows the TV to illuminate several images, okay, by the power when you connect it. But it's like little, it's like a little world, or a little world of little animals or little aliens that it's inside or inside the plasma, and that thing will let the TV function. It's like those little wires that you see, but I like how they compare it with the plasma when it forms the atoms out of gas, and the plasma that grows or that glows in the TV. Okay, now in this other part underneath you have several images, images that are related to technology, to the TVs, plasmas. How can the plasmas glow and let you see your favorite series or videos, okay, or games. Okay, the first image says, inside plasma TVs, millions of tiny chambers hold xenon and neon, which are noble gases. Okay. The next photo, when you turn the TV on, electric energy is supplied to the gases inside the chambers. Ionization, of course, and in plasma is produced. That's cool. The glowing plasma lights each one of the pixels on the screen. Pixels are the tiny squares of color that form an image when combined. So that means there's thousands or millions of small little pixels will make this image look better. Okay, the other image says plasma TVs run at a higher temperature because ionization releases energy. When the TV is turned off, these elements turn to their gaseous state. So that's why it's always important to unplug your chargers, unplug the TV, the fan, everything that requires of energy. Why? Because therefore, later if you leave it plugged, then it can produce an accident. Why? Because if you read right here, it says that the higher temperature runs through the cable. That's why it transmits its energy. That's why they always say unplug the cables, because we don't want accident. So you see how everything works throughout the energy. Okay, now let's look at the bottom information that's below the images. It says humanity has learned to manipulate the states of matter throughout history. We do this when we cool our drinks with ice cubes or watch plasma TVs. Can you think of another ways in which we change the state of matter of a substance to satisfy our needs? Okay, so now let's watch this word treasure. From now on, we're going to look at this word treasure, and later you're going to do activities with all the word treasures from the keys that each subject has, okay? So listen and repeat after each word, please.
Atom, atom. Chamber, chamber. Firm, firm. Steam, steam. To glow. To glow. Universe. Universe.
Okay guys, now take a look at this image. This image says plasma, energy and temperature. Now you see an ice cube. The ice cube is solid, but when it melts, it turns into a liquid, converting it into water, okay? But when water, that liquid, is freezing, it turns into a solid, okay? Now take a look to water, liquid. When there is vaporization, turns into gas, water vapor. But when that gas turns into condensation, becomes liquid, like water. Now, gas, when there is gas or water vapor, turns into ionization, and ionization converts it into plasma. Okay, the plasma, you can find it in ionized neon gas. Plasma, you can find it in neon signs, okay? The signs that will have this light that will glow, okay? Now, when this plasma does the state of deionization is when the gas turns into water vapor, okay? Now take a look on the bottom part. A plasma is an ionized gas. No definite volume or shape. It doesn't have volume or shape. Electrically conducted, and the most common state of matter. The most common states of matter are the ones that you see below. The sun, the neon signs, the fire, and the lighting, okay? That is some most common states of matter that the plasma will appear, okay? I hope that you enjoy this first video. Stay tuned for watching the rest of the other videos, okay? Love you guys.